Our second method of simplifying complex fractions takes into account something you have used before. But you create equivalent fractions. In fact, we did it earlier. Came up with some equivalent fractions. For example, 1/2, we know that if we multiply the numerator and the denominator both by the same thing, it's going to be equal to 3/6, which is an equivalent fraction. Same value, just a different appearance. So this is called a clever one because it does something, it accomplishes something that I want it to do. It's a purposeful choice of 3/3 maybe. Here I've done the same thing with 10/10. This would be my other clever one that's going to give me 10/20. So we're going to use this same thought with our expressions down here. So we're going to have to choose what we're going to multiply by, what clever one we're going to multiply by. So it says find the LCD of all of the little fractions. Now when I want to talk about little fractions, I'll be talking about this as a little fraction, little fraction, little fraction, little fraction. So that one has 4 little fractions. So we want to find the LCD of all of them. So if I come down here, I have a y squared. I'll just kind of write it here. I have a y squared, I have a y, I have an x squared, and I have an x. So my LCD for y squared and y would be the higher exponent, so y squared. And for the x squared and x, it's going to be the x squared. So I want it for all of them though. So this LCD is going to be x squared, y squared. All right. So it says multiply the big fraction. So here's my big fraction here by the LCD over the LCD. So I'm going to multiply x squared, y squared times the numerator and x squared, y squared times the denominator. Then what I'm going to do is I'm going to distribute it through both the numerator and denominator. So I'm going to multiply it times the first one, and I'm also going to multiply it times the second one. So it's helpful if you just rewrite this over here as well. So I'm going to multiply it times both. Same thing times the denominator, distribute it through, and I'm also going to multiply here. So notice in this method, I am finding the LCD of all the fractions, both numerator and denominator combined, and I multiply all of them by the same thing. All right, so now what I'll do is when I multiply here, you can see my y squareds are going to cancel, and that leaves me with x squared times x, which is x to the 3rd power, minus, when I multiply it times this fraction here, my y's cancel and leave me with 1y, and so I get 1 times x squared y, so I get x squared y, divided by, now I'm going to multiply to the denominator, my x squareds cancel, so I get y squared times y, which is y to the 3rd, and then here my x and x squared, it cancels to be an x there, so it's 1xy squared, so minus x y squared. The last step is to factor and reduce the results. Sometimes it won't reduce, but let's just check it and see. You see on this one, I see in the numerator x squared will come out, so this will give me x squared, and then I'm left with x minus y, divided by the denominator y squared is a GCF, and it leaves me with a y minus x. And these will cancel to be -1. So my final answer is going to be a negative x squared divided by y squared. All right, so let's look at another example here. So on this one here's my little, I have a couple little fractions. I have this 3/x, so I have an x, and I also have a 3x. So these are what I'm going to be looking at, the x and the 3x. So the LCD for those two things is going to be 3x. So that means that I'm going to multiply the numerator and the denominator by 3x and distribute it through both of those. So again, I'm going to write it on this side as well, so that I can cancel. All right, well, this doesn't cancel, so this is still just going to give me 15x minus, here my x's cancel, and that leaves me with minus 9 divided by, and then nothing cancels there, so it's 3x to the second plus, and then here my 3 and my x cancel, and I get plus 2. My next step would be to factor and result, but you can kind of factor and reduce, but you can kind of see that's not going to go anywhere, so I'm just going to circle that and say that it is the answer. One last one. See, this time, oh, I think I'll stop, and I think I'll pick that up on the next video.